In our increasingly digital world, the number of websites being created is growing exponentially. In January 2020 alone, there was over 1.74 billion websites in existence on the internet. Along with these growing websites, there are also a growing number of web pages associated. This brings us to the problem that we hope to resolve. We hope to provide a solution for our target users of site owners, developers, content creators, and all those involved in website maintenance. The greatest pain point that our target audience faces is, how does one maintain a healthy website? This can refer to needing to remove obsolete pages from years ago, gauging engagement performance with clicks and visits, or finding content leads for new campaigns based on released pages. So the problem that we aim to resolve is, how might we help users with their website maintenance?
My name is Christine, and I will be talking about our solution to the problem statement, which is our product, Revent. And so, what is Revent? Revent is a web application that allows developers to review their pages, display statistics about the pages, and it also allows users to leave comments and score rating, and the goal of the application is to allow teams to collaboratively review site pages. Some key features of Revent include a personal dashboard that displays user sites, display of the different pages of any particular site, along with important metrics such as the number of visitors on that page, the average time a user spends on that page, the average reviewer score, etc. And we also included the ability to view breakdown of ratings for a page and the breakdown of top reviewers for a page, and for users to also, of course, rate and comment on pages and to reply to comments. And so this last bit allows users of our website to communicate effectively and collaborate with one another through our application. And so the technology specifications for the front end, we mainly used React, and we also made use of the Material UI library, and so this really helped us build nice looking components without having to build up these components from scratch. And then any custom styling that we wanted to add, we did via CSS.
Hi, I'm Darby, and I'll be talking through the back end of our project. So to give a quick overview, we used Django to build an API, and then we used Python and the Scrapey framework to make a web crawler to crawl the websites and get our data. So for the API structure, we have 4 endpoints. We have users, websites, pages, and comments. For users, Django already has a great model built in for that, so we just used that. For websites, as you can see, we built this model which has an owner, which is a user, and a domain. Similar for page, it has a website, and then it has all these fields that hold its statistics, like the page URL, visitor count, time on page, creation date, and reviewer score. And then each comment also has a user and a page, and it has some text that the comment holds. One thing to note about this structure is that it's built in a way that each website only has one user. We did this because we intend that each website only has one owner in the system, and this just makes it easier to track. Our web crawler's main function was to print every single unique URL within a domain because we wanted to be able to get each page that you could review. Using a Scrapey spider that we wrote, we were able to write a script to do this. On the right, you're able to see a list of all the pages that our web crawler gave us. Unfortunately, there's a lot of limitations to the way we did this. First of all, we generated pseudodata for each page. What this means is that we didn't find an effective way to get data like the date created, etc. of each page, and so we just wrote a script to generate some fake data that we could use. Also, this is not connected to our site as of now. Originally, we wanted to put it up in a Lambda, but we ran out of time for this implementation. Our mentor was kind enough to set up the pipelines for us, but here's a brief overview of how they work. For both the API and the UI, source code is stored and managed in GitHub, and then as the code changes, that would trigger a build and deploy via the AWS code pipeline. On the API side, Docker images were built via code build, and then those images were then deployed via code deploy to an Elastic Container Service cluster for high availability. On the UI side, a production build of React was made via code build. Then those builds were deployed via code deploy to an S3 bucket set as the static web host. And finally, a CloudFront CDN was placed in front of the S3 for the reasons listed on the slide. Next, we'd like to talk about the lessons we learned during this project. One lesson that our mentor Tim was really vocal about was just diving into the code. It was really intimidating for us the first few weeks because we were using a lot of technology that were brand new to us. For example, most of us had not used Django. I, for one, had not used React, and I don't think any of us had used Docker before. But the more we got our hands dirty in the code, whether it was coding the front end, back end, or fixing bugs, it got easier. One thing that we had that was super helpful is that Tim held office hours every week. These are where we could ask questions that we had, pair program, or just hang out. And they were really helpful to make progress, especially because we were using technologies that we didn't have a lot of experience with and everybody had different experience levels. We could help each other at these parties and they were really effective. Another thing that really helped us as we got deeper into the project was assigning roles for each person. At the beginning, because we were all open to doing anything, we didn't define roles very clearly. This meant that everybody was trying to be an expert on everything, which was great, but we just didn't have enough time to do it. Once everybody got a taste of each part of the project, we decided based on interest what everybody would do. That ended up being me doing the back end and Christine and Tiffany doing more of the front end, and this really worked out well. We dedicated the last few days of our project to connecting all our individual parts and making sure they worked together.
We're all certainly very proud of the state of our current project, but also have many ideas on where to go from here, how to continue improving, and cool new features to add in. The first exciting add-on to our existing project would be tracking statistics. Currently on our web app, users must own their respective websites in order to track its data. For our current solution, searching for specific websites triggers the web crawler to be generated and to display pseudo data for the page metrics. A limitation that we faced is that we didn't have site permissions or access to live page metrics. With the mission of our project to facilitate and website maintenance, we believe that there is a definitive value in adding proper tracking statistics functionality. To implement this, we hope to determine the functionality to integrate with Google Analytics API. The benefits of our existing project is that it allows users to review specific page content, leave comments and ratings. Google Analytics would bring this to the next level by allowing users to more thoroughly review sites, visitors, behavior, and other performance metrics. Additionally, it would allow Revent to be populated with live data as opposed to pseudo data. Our next desired add-on to our existing project would be for data visualization. The current status of our web app is we provide a dashboard grid display of our pseudo site and page-specific information, as you can see on the right. For our next steps, we hope to add in a graph visualization feature for performance metrics such as day-to-day site visitors, providing users the ability to toggle between bar and line graphs and see the specific metric associated with that day. This would be especially useful to users in the cases of gauging page relevance or content campaign efficacy, as you can see the data fluctuations. Additionally, selected data should be exportable, which would allow for easier use of review. To implement this feature, we need to look into existing React chart libraries to take use of their functionalities and expand our Django page model with a new data field to account for this sequential data. The next feature that we hope to add in is for account personalization. Our current project allows for users to create their account, which should ideally let them see a dashboard of their site level information and page level information. The next steps to build upon for this is allowing for content owners to have a kind of to-do list of pages that they need to review and allow them to mark them as completed once the review is done, or if it's like in progress and needs further review. The next account personalization aspect would be allowing for websites and pages to be associated with a list of content owners, users with their associated contact information. To implement this, we need to add in the front end with React functionality, as well as expand our existing Django user model and site model to add in their respective data fields.
Thank you so much for listening to our presentation. Here is our contact information for the team as well as for the mentor. Thank you.